So, hello, thank you for coming. So, a little bit about me. My name's Becky. I'm a software developer at Ecometrica up in Edinburgh. You can find me on Twitter and most other places as RebQuoc. That's my email address. Slides will be up here. I won't be taking questions because I am going to run out of time. But you can contact me if you want to chat about anything that I talk about today. I unfortunately have to run to the airport pretty much straight after the talk, but feel free to contact me on Twitter or email. So this talk is about how we, as an individual company, went about upgrading a large established Python 2.7 codebase to Python 3.6. So I'll talk about some of the available tools that are out there to help you, our experience and our general approach, and some of the gotchas and pitfalls that we encountered along the way. This was just our approach. It's certainly not the only way to go about it. I'm by no means telling you that it's a single right way to do this. Instead, I just hope to give you a useful case study and share with you some of the lessons that we learned when we did this. So why did we and why should you even want to upgrade to Python 3? Well, the main reason is the obvious one, that the deadline for dropping Python 2.7 support is fast approaching. January 2020 is only a little bit more than a year away now. And despite the title of this talk, of course, your Python 2 code isn't going to shrivel up and die on the 1st of January 2020, but major projects, including Django, NumPy, SciPy, pandas, they're dropping or planning to drop support for Python 2. So in the not too far off future, you're going to be stuck with old versions that are only being bug fixed, and you're not getting any new features. So in terms of motivation to upgrade, that's the stick, but what's the carrot? Why should you want to embrace Python 3 rather than grumbling about the fact that you're being forced to use it? That would and has filled at least another few talks, so I'll just touch on a few of the highlights. There's some references at the end of the slides that go into some more detail. So the first thing is that Unicode thing. It gets rid of the overloaded string type, where string objects can represent either a textual or binary data. That link there has a nice description of how it came about and why Python 3 exists, largely to fix it. So in Python 3, a string is always a text string, and it's Unicode by default. We get better iterations, so everything's an iterator. Python 2 has lots of pairs of functions that do the same thing, except one's eager and one is lazy. Python 3 gets rid of all the lazy names and makes everything lazy. So everything's an iterator. Iterating over them works exactly the same way, but it doesn't create an intermediate list. So it's much harder to write code that accidentally uses up all your memory. There's some restrictions on comparators, so you can't do nonsense comparisons between different types anymore. And incidentally, in this example, foo is indeed greater than 4, according to Python 2. We get advanced unpacking, which I won't go into detail on, but you get this nice, if you can see it, nice star notation for unpacking both iterables and dictionaries. We get the option of keyword-only arguments in Python 3. So we get in this little example, this star argument means that the keyword argument following it has to be called by name. So that avoids accidentally passing too many positional arguments to a function and having them misinterpreted as keyword arguments. And f-strings. F-strings are awesome. F-strings are totally the reason to go to at least Python 3.6. As well as variable substitution, they can contain any Python expressions, including method and function calls. They're more readable, they're more concise, they're less prone to error, and they're also faster. Then there's async IO, the new concurrency module in Python 3.4, the new kind of hot thing, which I won't go into any more detail on than that. So obviously, there's more to be had from Python 3, but that's some of the highlights for us. So the project that we're working with, a little bit about that. Ecometrica's mapping platform is a big Django project. It does some cool things with GIS data. It works with GDAL and other underlying GIS libraries to import and transform mapping data sets, display areas of interest on an interactive map interface, and run user-defined queries across multiple data layers. It's about 8 years old. It's got about 70,000 lines of Python code in the core project. And it has a bunch of dependencies, including some typically temperamental GIS ones. Looks like this. We're looking at national parks in the Amazon there. We can upload and show display layers like this one. This is 2010 land cover. We can look at and zoom in and look at an individual area of interest and look at results of user-defined questions based on information from raster data sets. So things like carbon density, biomass within an area, or how events have happened in that area over time, depending on the underlying data sets that you put into the platform. So there's a bunch of useful tools out there to help you with your Python 3 upgrade. I'll take a look at a few of them, but this isn't by any means an exhaustive list. So firstly, you want to upgrade your project, and that's fine. But what about all your dependencies? Will they still work when you upgrade? There's a quick way to check, and that's the Can I Use Python 3 package. So it's a package, you pip install it. Then you just run it on your dependencies from the command line. You can run it in a few different ways, depending on how your dependencies are set up. It relies on projects being classified on PyPI as supporting at least one version of Python 3. So it's not perfect. Next, there's the 2 to 3 tool, which is really useful. It's usually installed as, with the Python interpreter as a script. And it reads Python 2 source code and applies a series of fixes to turn it into valid Python 3 code. So this is an example of a little Python 2.7 program. Doesn't do anything very useful. But we run 2 to 3 from the command line with the name of the file. And it outputs a diff of the fixes that it's going to make for Python 3. So if I can see this, you can see that. Okay, I can't get my pointer to work. So you can see that it's identified the print statements and the raw input statement that would change to input in Python 3. It's also identified the change to the exception syntax that we would need to make this valid on Python 3. Then there's linting. So PyLint has a Py3k flag, which will highlight Python 3 incompatible code. Running it on our example 2.7 program gives us a list of identified Python 3 issues. So note that PyLint has identified the exception.message line. That's invalid in Python 3. 2 to 3 didn't pick that one up. So, moving on to what we actually did. So, first of all, we needed to look at our architecture. So first things first, we needed to get Python 3 on our system. We're on Ubuntu 16.04, which ships with Python 3.5. But we wanted 3.6 because f-strings. So there was a little bit more setup involved, but only a little. We were doing this at the end of last year, so there wasn't Python 3.7 then. Otherwise, we would have done that. So we needed a few additional system packages to get Python 3 onto 16.04. But then after that, we're using virtualenv with virtualenv wrapper to install project dependencies. So we just needed to specify our Python 3.6 version when we created the virtualenv. And other than that, there really wasn't much else that we had to change in the deployment process. Things just kind of worked. So we had a kind of series of steps that we went through in doing the actual upgrade. So the first step was to do a bit of research, learn about the main differences between Python 2 and 3. The Unicode issue is the one that everyone knows about, but it's definitely worth reading up on some of the other differences before you start. Python3porting.com is a free online book, has guidance on porting to Python 3 and a pretty comprehensive description of the differences. I think it's a little bit out of date now, but most of it's still pretty good. And then the Python Future project has a cheat sheet, which is also a really useful reference. Next, we looked at the project's test coverage. So we're going to be using our unit tests as a tool to figure out whether the upgraded code was working. So it's important to have a decent test coverage before we started. Like most projects, ours probably could have been better, but it was okay. We didn't spend a lot of time adding additional tests just for this. It's hard enough to get a company to let you spend the time doing this anyway. So next, we looked at the dependencies. And this is the one that tends to put people off upgrading. So we want to use Python 3, but we rely on external dependencies, and dependency X, Y, and Z don't support Python 3 yet. So for quite a long time, this is as far as we got. We periodically checked the blocking requirements, and we put things off until the list looked a bit better. By the end of last year, the list of pending dependencies was looking manageable. There's more and more packages supporting Python 3, so every time we looked, it's like a little bit better. And this was the result when we ran Can I Use Python 3? Doesn't look so good. We've got 11 projects blocking our Python 3 upgrade. We had about 75 total in the requirements file, so could have been a lot worse. But things started to look up a little bit when we looked a bit more closely at this list. So 3 of these aren't things that we're actually using anymore. They're just still in the requirements file. So take them out and move on. That's good. We had 4 more, which showed up because they didn't have Python versions identified in the classifiers on PyPI. So they weren't correctly identified. And they all had Python 3 supported versions that we were either using or could upgrade to. This one, Python Scrubber, that wasn't compatible, but it also wasn't a very active project. There is a project called Bleach, which does the same thing, but better, so we changed to that. Django migration test case, that's like a little useful tool for testing your migrations. It wasn't compatible, but someone had already made a pull request to upgrade it to Python 3, so that work was done for us. This one, YAS3FS, is a system for syncing your local files with S3. That did cause us some problems. There was a pull request supporting Python 3 that was helpfully labeled add fixes to support Python 3, but didn't actually do very many of them. So we ended up putting some time into adding the remaining Python 3 support for it. And then this last one, Django hashed file name storage, that's a library that Ecomatico maintain, so our bad for not upgrading it sooner. And the same went for another couple of dependencies that we installed from private repos. We upgraded those ourselves. We maintained Python 2 compatibility for other users, and we added CI and tox to make sure that we were testing under multiple Python versions. So in the end, we whittled this list down to only a few things that really needed any significant effort to fix up. So the exciting bit, actually updating the code. It's quite a daunting process to start because you know that your changes are going to be so widespread. And in this respect, it's quite nice to be working with a Django project. So the code's like nicely divided up already into Django apps. So we worked app by app. We first ran 2 to 3 on the entire app and pretty much just accepted all of its suggested changes. We kept the backup files that 2 to 3 generates, so we could just easily check back on the previous version of the code. Then we ran the tests on just that app, fixed them up as necessary until they all ran. And we committed the changes app by app as well, which makes code review a little bit easier. And then finally, we ran Django. something invariably breaks, so we fix it again until it runs. And then we run the application manually and sort of check the functionality of that app as much as we can. So the next step was to do a bit of review and refactoring. And again, here, committing it app by app was useful and helped keep things together. It made it easier for other people to code review as well, although with changes that are this widespread, the code review is always going to be horrible. And in the previous step, we just fixed up the code until the tests worked. Now we went through and reviewed the diffs more carefully, particularly fixing the over-conservativeness of 2 to 3. So 2 to 3 is over-conservative. It's designed to convert Python 2 code to valid Python 3 code for any version of Python. And in some cases, it kind of adds extra things that you don't actually want or need. So the main cases of this that we found were converting new iterables to lists unnecessarily. So whether you actually need to convert it to a list depends on your current use case, and 2 to 3 often adds it where you don't necessarily need it, so you need to go and check those. And sometimes wraps print statements in extra parentheses, particularly if you were already using the print function syntax. It doesn't necessarily know whether you intended to print a tuple with Python 2, so it'll wrap everything in extra parentheses. This is kind of a specific case. So is callable was initially removed in Python 3 and reintroduced in 3.2. So if you're past 3.2, it doesn't need to be replaced, but 2 to 3 will still do it for you. And then there were places where we've been doing manual byte-to-string conversions, and in a lot of cases that got a bit convoluted at this stage because we'd just done what we needed, the bare minimum really, to get tests running and the app, test passing, the app running. So with a little bit more attention, a bit more refactoring, we could usually find that Python 3 allowed us to simplify things. And then you need to bear in mind that if you previously used from future import Unicode literals, you might encounter further subtle issues. And the Python Future project has a nice review of the pros and cons of using this for Python 2 to 3 compatibility that's worth having a look at. So next was linting. So once the porting's done, we run pylint with the py3k flag to check for Python 3 incompatible code. And we actually didn't do this because I didn't find out about it until later. We definitely could have avoided a few issues if we had. It's a really useful thing. 2 to 3 and this pylint with the py3k flag together are useful because they don't both catch everything. And then finally, we dedicated some time to front-end manual testing. So it's tedious, but it found issues that our unit tests didn't. And because our mapping platform is pretty specialized, we have GIS specialists who are familiar with the platform data, and it was really useful to have them look at it properly and ensure that processed data sets looked as they should, and that the queries generated expected results. Most of the developers are not experts in the particular questions that the analysts look at. And then everything was going so well, we thought we were more or less done, and we ran into one final hurdle, which is this library called GDAL to MB tiles. GDAL to MB tiles is a library that generates mapping tiles for display with something like Mapbox. It's an open source project, it's one that Ecometrica maintain. It does some extra stuff that GDAL doesn't do, so we still did need it. It has some extra fiddliness around installing it because it's dependent on GDAL. So we install it separately in our deployment process, and it's also minimally used in our actual mapping project. It's used in a related service. So it slipped under the radar when we were assessing dependencies and during the initial testing. Upgrading it to Python 3 turned out to be a mammoth task. I don't have time to go into it, but it was a nightmare. And it was just when we thought we were more or less done. So the moral to the story is check all your dependencies, wherever they're coming from. Don't just rely on your requirements file. So, gotchas, things that tripped us up along the way. So most of these are the result of a lack of thoroughness in the first step, actually doing our research. But some may be a little bit more obscure and not so immediately obvious. They're also not necessarily identified by the 2 to 3 tool. So the first one is rounding. This is probably not the one you think it is. So the rounding strategy has changed in Python 3. Python 2, it works the way that you were taught in school. So if you have an exact half, it gets rounded away from 0. I round 2.5 and I get 3, around 3.5 and I get 4. Python 3 uses bankers rounding, where exact halfway cases are rounded to the nearest even result. So when I round 2.5 in Python 3, I get 2. When I round 3.5, I get 4 again. It's kind of a subtle difference, and it only happens for exact halves, but it does produce the odd kind of weird rounding error that's hard to find. Bankers rounding is supposed to be unbiased, and therefore it produces better results with operations that involve rounding. Exceptions. So the core exception no longer has a message attribute, which isn't something that gets picked up by 2 to 3. So you have to use str.e instead of exception.message. Exceptions are often the things that you don't test, so it won't get picked up in your unit tests until you actually have something that throws the exception. The inbuilt hash function. So from Python 3.3, the inbuilt hash function is used at random seed for each Python process. It means that hash will return different values in different Python sessions. That was introduced to address the security vulnerability, so while you can turn it off, you really shouldn't. And there's a few places where we've been using hash on cache keys, and that meant that we were failing to find cached items between Python processes. And then pickling can be problematic, especially if you're trying to use Python 3 to unpickle objects that were previously pickled in Python 2. In addition, if you're using Django Redis without explicitly setting the pickle protocol, it'll default to the latest one, which doesn't exist in Python 2. Sorting things. So Python 2 allows comparisons between different types, and sometimes that gives you unexpected results. In Python 2, we can compare a string with an integer. Sometimes that kind of makes sense if you've got an integer that's expressed as a string. We can sort a list of integers and integers as strings in the same list, but it somewhat unexpectedly sorts them by type first and then by coerced int, so you don't get the result you expect in that sorted list. Python 3 insists on them being the same type, and it raises exceptions if they aren't. But the fact that Python 2 can compare and sort different types can hide bugs that you actually kind of had, but they only appear under Python 3. And since we generally can't identify what types are being passed around in Python, neither 2 to 3 or Pylint are very useful at picking up on those issues. So just from a rough estimate of the Git commits, this is the results of our upgrade work. So finally, some lessons learned. So upgrading any project will be hard work. There's lots of code to change. It doesn't have to be too painful, and it went more smoothly than we expected once we got started. But if you're not ready to embark on your Python 3 upgrade yet, you can make your Python 2 code Python 3 compatible as much as possible. In the more recent bits of the code base where we've done that, our upgrade process was much simpler. Get familiar with the differences. As well as helping you avoid some of the pitfalls, it will give you the opportunity to use the new features of Python 3 that you only have once you've upgraded. 223 is great. It's really useful. It can't do everything. So you're going to have to check everything that it finds, test to your friend, check all your dependencies, and be prepared to upgrade third-party libraries. Don't just wait for the maintainers to do the work for you. So, thank you very much. The slides are here. A bunch of other resources if you'd like to see them.
So thank you very much. Yes, I'm afraid again we're out of time for questions, but perhaps they could, if you have any follow-up with Becky, as she suggested. So let's thank her once again.